Hello, and welcome to our presentation of Artificial Intelligence in Enterprise Systems. Our team, consisting of Bernie Mosley, Christian Tungle, and myself, Judith Berg, will be discussing the integration and implementation of artificial intelligence in enterprise systems. First, Christian Tungle will be discussing future work in enterprise systems with a focus on the interplay of people and machines. Christian will address the humanization of digitization, followed by myself, Judith Berg. I will be discussing the elements necessary for the utilization of artificial intelligence in conjunction with enterprise resource planning systems to create intelligent manufacturing. Lastly, Bernie Mosley will be discussing an actual artificial intelligence solution which can assist enterprises in creating real-time data mined from the internet through news stories and social media postings. Using the tool with the generated real-time data, this tool enables businesses to address the impact future events may have across their enterprise. And now, Christian Tungle will discuss future work and enterprise systems.
Hi, my name is Christian Tungle, and I will be covering future work in enterprise systems. In researching business and information systems, the current discourse revolves around automation. Machines now have the ability to facilitate automation in business areas like blockchain and smart contract. These examples show automation in large parts of the supply chain. In discussing the future of work, it poses the question about the interplay of people and machines. The following figure shows how we can differentiate between the social intensity and the technical intensity of work. These are defined into the four basic types of work systems shown. In Type A, conventional business is used to define systems with comparatively low social and technical intensity. Enterprise resource planning systems are an example of systems that follow a logic of workflows or transaction, thus transaction logic, conducted by people and machines. In Type B, machine business are characterized by high technical intensity and low social intensity. Examples of this include booking services like Kayak or Booking.com that compare thousands of offers in fractions of a second. Thus, it is an automation logic in this dimension. In Type C, people business is a dimension where people are able to bring in human capabilities like creative thinking and social behavior to these environments where man and machine must coexist. These are important contributions as these services are characterized by high social intensity and low technical intensity, or collaboration logic. Examples include counseling work. In Type D, people business, or combination logic, innovative technological services and value-adding social services should be combined in hybrid arrangements of man and machine. This is where people may interface with both users and machines. In this regard, automation can assist human actors in improving service to customers and society. Examples of this combination logic are robo-advising that identifies and compares investment opportunities based on user preference. So machines will deliver larger parts of the work in the future, which will challenge humans to provide added value, but will also provide opportunities to do so and to create new levels of value. As organizations further explore this area, it is important for them to research how such hybrid combinations of people and machines contribute to businesses and to design innovative and value-adding business models through these combinations. The influence of IT technologies, and in particular, artificial intelligence technologies, or AI, on the future of work develops along the innovation axis of optimization, transformation, and disruption. According to McAfee and Brynjolfsson, the rapid development of AI technologies in recent years has created a great deal of uncertainty about the implications for the future of work. AI technologies are currently successful in regulated environments, such as games. AI systems enable autonomous actions such as autonomous driving. The same is true for work situations in which humans and robots collaborate. The robotic process automation, or RPA, uses AI technologies to bring decision-making intelligence, flexibility, and adaptability into the business process environments. A large part of the current AI projects addresses the optimization of existing business tasks. We are currently seeing this in chatbot projects that optimize customer contacts in call centers. Industry 4.0 is currently its transformational approach. This is where provisions of individual product service systems at the marginal cost of mass production. Examples of innovative transformation initiatives include the Internet of Things platforms by multinational enterprises. So how can companies and industries react to this impact of AI technologies? Well, they can do so by utilizing AI technologies and optimization, which is local in nature with little indirect impact. So in terms of traditional retraining, measures can be used as well. This requires transformation initiatives in all areas of the company, including marketing, sales, human resources, and general administration. Thus, it is important to refocus corporate strategies, train workers to meet these changing needs, reorganize corporate organizations, and transform product and service offerings. Enterprise Systems, or ES, covers all organizational-wide IS as well as associated platforms. However, looking forward, ES will be subject to significant changes as we see more applications empowered by AI, primarily due to substantial advancement in machine learning algorithms. So by adding AI capabilities to enterprise systems, they are enabled to sense and dynamically respond to their environment as well as continuously learn. The Evolving Intelligent Enterprise System, or IES, will represent a new class of systems and become a key element in the future of work environment. IES are geared at boosting the value added and thus improving business results. It also aims to increase productivity, for instance, enabling full automation of selected tasks. Besides automation, it may also have the goal to increase task performance and human-system cooperation. So it also may contribute to humanistic goals, such as emphasizing individual human values or helping employees find a better balance between work and life. In this research, many experts like Hamill state that today's enduring management practices do more to encourage employees' obedience, diligence, and expertise than to tap to their higher level values like passion, creativity, and initiative. So what future-focused leaders understand that they need to do for their organization is the following. First is to adopt a leadership style that leaves room for experimentation and for making mistakes along the way. Innovative teams encourage and thrive on a diversity of backgrounds, perspectives, and personalities. The second they need to do is enable everyone to understand the organization's purpose. Viewing business transactions as win-lose, purpose-led companies understand how everyone can benefit. With this mindset, employees are value contributors, customers are advocates, suppliers are business partners, and goals embrace the triple bottom line: economy, society, and environment. The third is empower people to be creative and take actions to achieve their goals. Ensure leaders to somewhat get out of the way or encourage people to take initiative to look for ways to help the company thrive whenever they see an opportunity. Empower distributed decision intelligence to increase decision quality and foster ownership and autonomy. Give more decision-making powers to the people who are affected by the decisions. Empower employees, put them in charge, give them more freedom, but also for more self-responsibility in return. The fourth would be organized differently. Innovative companies have more fluid structures. Employees form dynamic teams to address opportunities and set their own paths to achieve objectives. Teams include all the roles that are necessary for the company to succeed and are set up to ensure end-to-end responsibility for achieving objectives and customer demands. The fifth is consider the team set up carefully to foster more accountability and autonomy. Not only who is on the team, but how they get there is important. Provide opportunities for people to choose their project assignments, enable self-assessments to tasks and responsibilities, recognizing that people are more motivated when they decide where their unique talents can best contribute. And for the 6, understand that peer group competition and team pressure are powerful motivators. Replace today's traditional management controls with mechanisms that promote more information sharing within the team. With this in mind, there are solutions like SAP Future Work and SAP Work Life that have approaches to transform the ways individuals and organizations learn and develop competencies, increase internal job mobility like job trading, and help self-managed teams effectively plan their resources. Solutions like the SAP Future of Work teams helps companies tap the unique human capacity to innovate by developing technology solutions that make it easier for companies to embrace new management practices and new ways of working. SAP Work Life is a solution that enables companies to put people first.
Thank you, Christian. Hello, my name is Judith Berg, and I will be discussing the utilization of artificial intelligence in conjunction with an enterprise resource planning system to create intelligent manufacturing. I will be also discussing some of the advantages of this implementation. The era of big data has brought about the necessity for corporations to organize the enormous amount of data generated on a daily basis. Utilizing artificial intelligence with an enterprise resource planning system provides advantages across the entire enterprise. These advantages include higher quality for the customer, better efficiency for workers, and greater environmentally conscious production to benefit future generations. Ultimately, organizing the vast amount of information generated across the enterprise results in a more competitive marketplace. Intelligent manufacturing is composed of 5 layers. They are the resources capacities layer, the ubiquitous network layer, a service platform layer, an intelligent cloud service layer, as well as a security management and standard specification system. The first layer, the resources capacities layer, consists of hard and soft manufacturing resources in addition to manufacturing capacities. Some examples of hard manufacturing resources are robots, machining centers, and big data software. Soft manufacturing resources refer to areas such as sales, management, and maintenance. The second layer, the ubiquitous network layer, includes physical items such as programmable switches and communication satellites. It provides an open network where higher level and lower level components may communicate with one another. It includes software consisting of virtual routers, virtual firewalls, and virtual wide area networks. Lastly, there is intelligent sensing, which enables data to be collected in various ways, such as with sensors in a wireless sensor network. The third layer, the service platform layer, includes the ability to pair the locations of physical manufacturing resources and capacities to virtual manufacturing resources and capacities. It also provides cloud services and the intelligent manufacturing platform, which provides system operation services, in addition to enabling the user to develop a customized user experience. The fourth layer, the intelligent cloud service application layer, provides 4 modes for the human and organizational aspects of intelligent manufacturing and addresses many facets of the intelligent manufacturing system, some of which includes autonomous intelligent sensing, collaboration, and the environment. The fifth layer, the security management and standard specifications layer, safeguards the identification of the intelligent manufacturing users, grants secure access to resources, and provides data security via an autonomous security system. It also provides the foundation for the standards of the entire platform. Various technologies support intelligent manufacturing and are defined as general technology, intelligent manufacturing platform technology, ubiquitous network technology, product lifecycle intelligent manufacturing technology, and supporting technology. General technology supports and forms the intelligent manufacturing ecosystem and is formed by technologies such as space-air-ground system architecture technology and intelligent manufacturing security technology. Intelligent manufacturing platform technology employs elements such as analysis, mining technology, and Internet of Things technology. The ubiquitous network technology is an integrated network composed of many different types of computers, which can operate in a myriad of locations at any time. Product lifecycle intelligent manufacturing technology revolves around cloud innovation design, operation, simulation, and service guarantee. Supporting technology is provided by Artificial Intelligence 2.0, which includes communication, manufacturing, and professional technologies such as modeling, simulation, and 3D printing. Two of the predominant leaders in developing intelligent manufacturing are the United States and Germany. The Industrial Internet debuted in 2012 in the United States, and its sister Industry 4.0 plan debuted in 2013 in Germany. The goal for both systems was to gather data in real time and analyze it in order for factories in the United States and Germany to revolutionize their approach to manufacturing and become leaders in their respective industries. In Amberg, Germany, a Siemens company developed a factory according to the Industry 4.0 plan, and approximately 75% of the factory is automated, and although production has risen to 8 times more than it was in 1989, the number of employees is approximately the same. In spite of their strides with integrating artificial intelligence and the enterprise resource planning systems, a lot of research and development remains. There is a realization that there must be a collaboration between the ERP software developers and intelligent manufacturing personnel in order to incorporate the necessary software changes to increase an organization's competitive edge in its respective marketplace. Unfortunately, today's traditional ERP systems do not have the ability to relay real-time data, which is critical for technologies such as autonomous decision-making used in the artificial intelligence ecosystem. Defining the elements of intelligent manufacturing architecture, such as robots, virtual firewalls, sensing units, human resources, and manufacturing resource capacities, are critical decisions, all of which are made by humans. Despite its autonomous nature, the success of implementing artificial intelligence in an enterprise is largely dependent on the personnel involved. This concludes my discussion of the utilization of artificial intelligence in conjunction with an enterprise resource planning system to create intelligent manufacturing. And now, Bernie will discuss an actual artificial intelligence solution which can assist enterprises in creating real-time data which enables businesses to address the impact future events may have across their enterprise.
Hello, my name is Bernie Mosley, and I will be discussing an article titled An AI Planning Solution to Scenario Generation for Enterprise Risk Management. It was authored by Shirian Sorbani, Anton V. Ravoff, Michael Katz, Octavian Udrea, and submitted as a part of the 32nd AAAI Conference on Artificial Intelligence, which took place in 2018 in New Orleans, Louisiana between February 2nd and 7th. Risk management, as defined on Wikipedia, is the identification, evaluation, and prioritization of risks followed by coordinated and economical application of resources to minimize, monitor, and control the probability or impact of unfortunate events, or to maximize the realization of opportunities. This was traditionally performed by a group of people, both experts and non-experts, sitting around dreaming up of possible scenarios, no matter how improbable or impossible. They would come up with possible solutions to these scenarios if the risk was deemed either probable or thought of as catastrophic. Some examples of risk management would be to determine the effects on the organization in the event of a natural disaster or the collapse of the stock market, just to name a few extremes. It also entails lesser extreme risks, like what if it was found that fraud was committed by a board member and how it might affect the share price of the company. The authors came up with an AI solution to creating risk management scenarios that would use real-time data mined from the internet through news stories and social media postings. The system that they created is called the Scenario Planning Advisor. The Scenario Planning Advisor, or SAP, is described by the authors as a decision support system to assist organizations in generating future scenarios, identifying and managing emerging risks. A category of risk associated with the changes in the global or local economies, politics, technology, society, and others. With this tool, a business can address the possible impact of elections, economy, and other factors to determine their likelihood and impact on the organization. This will allow for quicker decision-making and reactions to events as they are happening, which can lead to better responses to situations and lower losses to the organization. The SAP works on three components: the news aggregator, the domain knowledge, and the scenario generation and planning. The news aggregator deals with analyzing the raw data coming from the news and social media feeds. With the help of keywords supplied by the developers and other learned analytics, the news aggregator looks for mentions throughout its search to find data that will be sent to the scenario generation and planning component. These mentions may include people, places, organizations, or anything that a subject matter expert, or SME, might feel is useful. The domain knowledge component is provided by a combination of forces models and forces impacts that are used by the scenario generation and planning component in the creation of scenarios and determining their likelihood. The forces models are generally coded from mind maps provided by the SMEs and are a path similar to a decision tree to start with a cause and end with a consequence. Alongside the forces models are the forces impact. This is where the information regarding the impact of the consequences that are determined from the forces model are scored for relevance based on the information provided. This information is usually provided through a questionnaire. According to the authors, the SPA is most effective if the questionnaire is generated in such a way that there are three possible rankings for each impact questioned: high, medium, or low. They do mention that the more specific that the range can be, the more accurate the SPA is with the results. For example, an answer of medium may not be as specific as a ranking of 68 out of 100. Now that the data is collected by the news aggregator, and the causes and consequences along with their impacts are coded into the system, then the scenario generation and planning component is able to take over and compute the data provided. To do this, the authors describe the process as follows. To compute a set of scenarios, we perform the following steps. 1. Follow previous work on plan recognition as planning to compute away the observations and ensure that at least one goal is satisfied. 2. Compute a set of high-quality plans on the transformed planning problem. And 3. Cluster the resulting plans into scenarios so that similar plans are grouped together. The authors used several business teams at IBM who deal in risk management as their test deployment for evaluating the SPA. By all accounts, the users were extremely pleased with the system. Since there was no previous system that can be compared to the SPA, it is difficult to perform a side-by-side comparison. That being said, with the performance and experience that was gained through the pilot deployment at IBM, the authors are pleased with the SPA as a beginning step in the evolution of AI in risk management. This concludes my discussion of an AI planning solution to scenario generation for enterprise risk management.
Thank you, Bernie. Today, we have spoken about integrating artificial intelligence in enterprise systems. Christian Tungle addressed future work and enterprise systems with a focus on the interplay of people and machines, followed by myself, Judith Berg, where I address the elements necessary for the utilization of artificial intelligence in conjunction with enterprise resource planning systems to create intelligent manufacturing. Lastly, Bernie Mosley provided an example of an actual artificial intelligence solution which could assist enterprises with managing the impact future events may have across their enterprise. Clearly, the implementation of artificial intelligence across an enterprise has enormous implications, from the impact on human resources to the changes across the manufacturing sector. Bernie's example of the Scenario Planning Advisor, an artificial intelligence solution, provided insight to the powerful advantages the use of artificial intelligence may provide to enterprises. The integration of artificial intelligence across an enterprise is clearly a complex undertaking, and ultimately the success of such a monumental venture requires extensive planning and patience in order to accomplish the goals of the enterprise, enabling them to thrive amongst their competition. This concludes our presentation of artificial intelligence in enterprise systems. We have listed our sources for our presentation. If you have any questions, please post them in our online class discussion or email us and we will answer them. Thank you.